In this video, I'm going to walk through the process of how to solve a quadratic equation by completing the square, and we'll do a couple of examples here. The first thing that I want to remind you of is that for a polynomial x squared plus bx, the constant needed to make a perfect square trinomial is b over 2 squared. That is the constant we're going to have to add on to it to complete the square. Okay, so the whole idea around completing the square is that we're going to make a perfect square trinomial that we can factor as a binomial times a binomial, and then use the square root property to solve it. So in this first example of x squared plus 8x equal to 9, one of the first things that you want to do when you're solving by completing the square is get the x squared plus bx by itself on one side of the equation. In this case, we have x squared plus 8x. In addition, the leading coefficient in front of x squared has to be 1 in order to solve by completing the square. So in this case, that's in place, and we have the x squared plus 8x on one side of the equation. So what I'm going to do is I'm going to complete the square on x squared plus 8x. So I'm going to have x squared plus 8x, and what would we have to add to that to complete the square? So in our case, b is 8, right? And I have to divide that by 2 and square it. So that's going to be 4 squared, which is 16. Okay, so I'm going to add 16. Now, what you do to one side, you must also do to the other. Okay, so since I'm adding 16 to the left-hand side, I have to also add it to the right-hand side. Okay, so now in the next step here, I'm going to factor x squared plus 8x plus 16. If I did it right, I should have a binomial times a binomial, right? The same one. So this factors of 16 that add to 8. Well, 4 and 4, right? So I'm going to have x plus 4 times x plus 4, or x plus 4 squared. And 9 and 16 is 25. Okay. So now we're positioned well to use the square root property to solve this. Okay, so in taking the square root of both sides, I'm going to have x plus 4 equal to plus or minus 5, right? The square root of 25 is 5. Okay, so now I have to subtract 4 from both sides, so I'm going to have x plus 4 minus 4 equal to negative 4 plus or minus 5, right? So x is equal to negative 4 plus or minus 5. So we're going to have either x equal to negative 4 plus 5, which is equal to 1, or x is equal to negative 4 minus 5, which is equal to negative 9. Okay, so the solution set is negative 9 or positive 1. Okay, so this is the general process for completing the square. Now I want to point out, if you get nice integer values like that, what that means is that in the beginning this quadratic would have factored. And factoring is the easiest way to solve a quadratic, by the way. You can use the quadratic formula, that will always work. You can always use this process of completing the square, this will always work. But if you get some nice values, sometimes that means that it would have factored nicely. So just as an aside here, I want to look at that, the factorability of this. So x squared plus 8x equal to 9. If we set this equal to 0, I'm going to have x squared plus 8x minus 9. Pardon me, I'm skipping some steps here and showing the subtraction from each side, but I'm subtracting 9 from both sides. And factors of negative 9 that add to 8. Well, positive 9 and negative 1, right? 9 times negative 1 is negative 9. 9 minus 1 is 8. Okay, so that means that x plus 9 equals 0, or x minus 1 equals 0, right? X is equal to negative 9, or x is equal to 1, right? Is that not what we got with completing the square? Okay, yeah. Now factoring, if you see that it factors, it's usually a little bit easier than any of the other methods. So that's one thing to note. Here we were tasked with solving it by completing the square. We're trying to get practice with that concept, so always follow the directions, obviously. But if you're asked to solve a quadratic using any method, I always look for that first. You know, does it factor? It's usually easier. Okay, Okay, so look at the r squared minus 10r minus 22 equal to 0. So we're going to solve this by completing the square. It's set up like you just want to factor it, right? But this one isn't factorable, is it? So if we look at the negative 22, I'm either thinking 22 and 1 or 2 and 11. 10 is only 1 away from 11, so it's never going to work in order to get the factoring done, is it? So by completing the square, we want to start with this equation looking the same way the first one did, with the r squared minus 10r on one side. So the first thing I'm going to do is to add 22 to both sides. So I'm doing that here. R squared minus 10r minus 22 plus 22 equal to 0 plus 22. And then I have r squared minus 10r equal to 22. So take that leading coefficient. In this case, it's negative 10. Whether you take the positive or negative with it, it does not matter because you're going to square it. So negative 10 divided by 2 is negative 5, but when you square it, it's positive 25. So you're always adding a number anyway. Okay, so that's what we're going to add to both sides of the equation, right? You got to keep the equation balanced. So since we want to add it to the left, we have to add it to the right as well. Okay, so r squared minus 10r plus 25. So the left-hand side factors, right? It's a perfect square trinomial if we did it right, right? So factors of 25 that add to negative 10, negative 5 and negative 5, right? So I'm going to have r minus 5 quantity squared equal to, so 47 is not a perfect square. In fact, it's a prime number. There aren't any factors we can pull out of that root or anything. So from here, I'm going to add 5 to both sides because I'm still trying to solve for r. So I'll have 5 plus or minus the square root of 47. So r equal to 5 plus or minus square root 47. The solution set is 5 minus the square root of 47, as well as 5 plus square root 47. Okay. And those are exact solutions, right? Certainly you could take them into your calculator or Desmos and find an approximate solution. But we're going to list our solutions in exact form.